Welcome to ENT students. Today I'm going to tell about physiology of nose. Functions of nose are respiration, air conditioning of inspired air, protection of lower airway, vocal resonance, nasal reflex functions, and olfaction. Respiration. Nose is the natural pathway for breathing. Mouth breathing is an acquired act through learning. The nose also permits breathing and eating to go on simultaneously. During quiet respiration, inspiratory air current passes through the middle part of the nose between the turbinates and nasal septum. Very little air passes through the inferior meatus or olfactory region of nose. Therefore, weak odorous substances have to be sniffed before they can reach the olfactory area. During expiration, air current follows the same course as during inspiration, but the entire air current is not expelled directly through the nerve. Friction offered at lamen nasi converts it into eddies under cover of inferior and middle turbinates and ventilates the sinuses through the ostia. Nasal cycle. Nasal mucosa undergoes rhythmical cyclical congestion and decongestion, thus controlling the airflow through nasal chambers. When one nasal chamber is working, total nasal respiration equal to that of both nasal chambers is carried out by it. Nasal cycle carries every 2.5 to 4 hours and may be characteristic of an individual. Air conditioning of inspired air. Nose is called the air conditioner for lungs. Filtration and purification. Nasal vibrissae at the entrance of nose act as filters to large particles like fluffs of cotton. The front of the nose can filter particles up to 3 micrometer, while nasal mucosa traps particles like dust, pollen, and bacteria as fine as 0.5 to 3 micrometer. Particles smaller than 0.5 micrometer seem to pass through the nose into lower airways without difficulty. Temperature control of the inspired air. The mucous membrane, particularly in the region of middle and inferior turbinates and adjacent parts of the septum, is highly vascular with cavernous venous spaces, which control the blood flow and increases or decreases the size of turbinate. This also makes an efficient radiator mechanism to warm up the cold air. Inspired air, which may be at 20 degrees Celsius or 0 degrees Celsius, or even at sub-zero temperature, is heated near the body temperature, 37 degrees Celsius. Similarly, hot air is cooled to the level of body temperature. Humidification. This function goes on simultaneously with the temperature control of inspired air. Air is dry in winter and saturated with moisture in summer. Nasal mucosa membrane adjusts the relative humidity of the inspired air to 75% or more. Water to saturate the inspired air is provided by the nasal mucous membrane, which is rich in mucus and serous secreting glands. About 1000 ml of water is evaporated from the surface of the nasal mucosa in 24 hours. Moisture is essential for integrity and functioning of the ciliary epithelium. Protection of lower airway. Mucociliary mechanism. Mucous blanket consisting of superficial mucous layer and deep serous layer, which are floating on the top of the cilia and constantly beating to carry it like a conveyor belt towards the nasopharynx at a speed of 5 to 10 mm per minute. And a complete sheet of mucus is cleared into the pharynx every 10 to 20 minutes. The inspired bacteria, viruses, and dust particles are entrapped on the viscous mucous blanket and carried to the nasopharynx to be swallowed. The turbinate almost doubles the surface area to perform this function. About 600 to 700 ml of nasal secretions are produced in every 24 hours. Cilia beats 10 to 20 times per second at room temperature. Rapid effective stroke, in which the cilia extended and reached the mucous layer. Slow recovery stroke, in which the cilia bends and travels slowly in the reverse direction in thin serous layer, and thus moving the mucous blanket in only one direction. In immotile cilia syndrome, cilia are defective and cannot beat effectively, leading to stagnation of mucus in the nose and sinuses and bronchi, causing chronic rhinosinusitis and bronchiectasis. Movements of cilia are affected by drying. Drugs like adrenaline excessive heat or cold, smoking, infection, and noxious fumes like sulfur dioxide and carbon dioxide. This is conveyor belt mechanism of mucus blanket to entrap and carry organisms and dust particles. As you can see, superficial mucus layer and deep serous layer and cilia. Enzymes and immunoglobulins. Nasal secretions contain an enzyme called muramidase, which is a lysozyme, which kills the bacteria and viruses. Immunoglobulins like IgA and IgE and interferon are present in the nasal secretions and provide immunity against upper respiratory tract infections. Sneezing. It is a protective reflex. Foreign particles which irritate nasal mucosa are expelled by sneezing. The pH of nasal secretion is nearly constant at 7. The cilia and the lysozyme act best at this pH. Alteration in nasal pH due to infection or nasal drop seriously impairs the function of cilia and lysozyme.